Oh, está bien.
Siempre para los simposios ando un poco con el internet, es como me pasa que tengo que grabar. Pero bueno, me parece que todo está
Estamos, sí, por términos de... Sí, espero.
I don't even know what it is.
What's in this track is that you bring a direction
Almost
and
season.
you take a sip.
What the fuck is a tree? I'll get out there and just do that for like 7 minutes.
Yeah, I'm gonna give you guys a demonstration of what I can show you.
They translate.
Yeah, but
All good.
Estamos. Buenas tardes. Buenas tardes. Buenas tardes. Muchas gracias a todos y todas por tomarse este ratito en la tarde, familias, por estar acá acompañando a sus estudiantes y a coordinadores de pasantías o quienes han estado a cargo de estos estudiantes, profesores y demás por sacar el tiempo y estar acá acompañándonos. Esta tarde tenemos la oportunidad y el privilegio de mostrar y compartir un poquito de lo que fue el trabajo de este grupo de estudiantes de la Universidad de Carnegie Mellon en sus proyectos de pasantía, en los cuales han dedicado bastante tiempo con este clima que hemos tenido, con mucho trabajo afuera, que ha sido todo un reto poder coordinar y hacer en diferentes temas. Tuvimos una variedad de temas a nivel de análisis de datos, tuvimos múltiples aspectos que estuvimos analizando. Algunos tenían que ver un poco con temas de reforestación, otros tenían que ver con aves, algunos con proyectos que el instituto tiene en términos de recolección de datos climáticos. También tuvimos otros temas mucho más sociales, estuvimos involucrados con la tilichera este año, tuvimos la oportunidad de compartir con Moki para conocer historias de vida, un proyecto un poco más amplio que está iniciando el instituto, dando continuidad. Entonces vamos a ver una variedad de presentaciones en diferentes temas. Muchas gracias a quienes coordinaron las pasantías y a quienes nos apoyaron con tiempo, Debbie por todo su tiempo, a Lucky por todo su tiempo, a Luisa, y quienes más estuvieron apoyando a los estudiantes. Por allá Felicia también estuvo involucrada con otro proyecto en el caso de Hugh. En fin, tuvimos un montón de personas de la comunidad que se involucraron para hacer posible esto. Summarizing a little bit of what I'm saying. Thank you guys for all your work. Thank you Peter, thank you Teresa, who is not here but was an important part at the start of this program. for all your time. This is a summary of all your time in the involvement with the internships. So this will be a glimpse of the work you have done throughout this last couple of weeks, even with the weather being an obstacle in many cases, or, well, a good obstacle, I want to say. It's good to have the rain. So thank you for all your work and time within these internships. There is a variety of things, as you already know. Some of them have to do with natural science, some of them are more socially oriented. So thank you for the internship coordinators, Lucky, Debbie, and also Felicia, who was involved with in the case of Hugh. Thank you for all your time. Well, I'm also missing Paola from the teacher, which was an important piece. So that being said, this will be the order for the afternoon. Our hope is to wrap it up around 3 o'clock, 3 something, and we'll wrap it up with coffee. So afterwards, we'll have a chance to go and grab some snacks and coffee. Después de esta es más o menos la agenda para la tarde, entonces tenemos más o menos 10 minutos por presentación, incluye las preguntas y posteriormente a eso tenemos un espacio para café y bocadillos, entonces esperamos que nos acompañen posterior a eso. Y siguiendo ese orden, la primera persona que nos va a estar ayudando con la primera presentación, que es un para visualizar datos climáticos, es Ethan. So Ethan, you're going to be the first person. So thank you.
Okay, hello everybody. My name is Ethan. Thank you for introducing me. So my project, my internship during this month has been making visual analyses of the weather data that have been sent to me by the Institute and by Casa Laval. So the data I received was, as I said, from the Institute. That included data about like the high and low temperature of the day, the wind speed, like the wind direction, the heat and cool degree days, which are measures of how much energy it takes to heat or cool a building. And then I also received data from Casa Laval, which goes back to 1980, but only includes the data about the rainfall and the high and low temperature of the day. So my first step was getting the Google Sheets that were sent to me in, kind of in this format, and then changing them into something that can be used for statistical analyses, like this. And so the tool I used is called Carnegenie. That's R is a programming language, and then Shiny is like an extension that allows for graphical user interfaces. And this is important because it includes like how it allows you to interpret and like visually analyze the data. Okay, you'll be redirected for this. You don't need it. You don't need it. Don't worry about it. Okay, so this is the app I made. So there are a few different pages up at the top. So this first one, you can just see, you can click which variable you want to see information about, like rainfall, temperature, average wind speed, and it shows you that data across the year for however many years you want to compare to each other. So you can go back to 2011. Some of the data is not like complete, like for example this one only has a few months worth, but this allows you to kind of compare different things over time. The next two tabs, you can see in the list the data like across 1 year for each day, and this has the same options again, like the mean temperature, high and low, rainfall, and wind speed. Back to 2011, up to 2023. And then this yellow line in the middle is a smoothed average, so you can kind of see the general pattern over time. Yeah, you can see the rainfall. Yeah. And this is the same page as before, but this uses the Casa Laval data, so it's you can go back to 1981 and see the different like patterns over time of like the temperature and the rainfall. My next tab is a bit of a work in progress, but it shows you the wind direction. So 0 degrees in this case is east, 270 is north, etc. And it lets you see that for different years. It's a bit of a work in progress because if you don't have 2017 selected, then it only goes to 180. which is overdue, but you don't need to worry about that. I'm working on fixing it. And then this last page I have is the Laval data, so you can see kind of more of a trend over a longer period of time. And so on this one I found, this is the max temperature. And I found that there hasn't really been like much of a steady increase over time, but I did notice this pattern where like the temperature kind of decreases around 2000, goes up around 2005, goes back down around 2010. This may correspond to global weather patterns such as like El Nino or La Nina. So it's interesting, you can see that here. And also with the mean temperature and the rainfall as well. And then I also made the same thing, but I also made a version in Spanish because I thought this would be kind of more accessible to the community here because I know we don't all speak Spanish, but I mean English. So this has all the same features, but everything is just translated. Yeah. So, so further work I'm working on in my last few days here, I'm going to be publishing this online, hopefully within the next few days so that anyone will be able to access it anytime without having to have code and stuff on their computer. And I'm also working on being able to predict like future weather data, like the temperature or like the rainfall for future days, based on the data that we currently have. Yeah, so thank you for your time. Feel free to ask questions, or if you have any suggestions for things you'd like to see in the app, let me know. Yeah, thank you.
Really cool. Really cool.
Thanks.
So thank you for your work. In the future, if we need to feed more information, does it work like it will continue operating in such a way that you can feed information and then it automatically updates it, or you need to do it?
So this uses currently files that I have downloaded onto my computer. So you would need to update the files and it should still work. Also, like all the data I receive, I had to kind of change into a different format with code. And I can send that to you guys as well if you'd like. So you can just like upload the file and then use the code I wrote to like change it into a format that the computer can understand, and then it should work the same.
Okay, thank you.
Yeah.
It's super cool. And I'm watching Lois's expression too because she's been doing it. But my question is, when you did the regression over time for the temperature, have you done them for the wind and you've done them for all of the different categories?
I only did the regressions for the data from Casa Laval, which only has the min, max, and rainfall, because that kind of was a long period of time to work with, but I could definitely do it for the Institute data as well.
That's really interesting.
Yeah.
I see that.
Thanks.
And is that something that you already knew how to work with, the R shiny?
Not really. I did kind of already know R, so like making the graphs and stuff, but I did kind of have to learn how to make that into like the user interface. It wasn't like super difficult, but there was a lot of Googling on how do I do this? So kind of.
Thank you.
So you mentioned that you want to have that like a link to access that.
Yeah.
So you can get it through our webpage.
Yeah, you should be able to. Yeah. Currently, the site I have looked at online that lets you publish these kind of limits how much you can use it unless you pay for an account. So you won't be able to I think it's like 25 hours per month. But I might also try to see if I can get a subscription through Carnegie Mellon. So yeah, but there should be a link. Okay, anything else? Okay. Yeah. Oh wait, I got it. Sorry.
well, and I am going to be talking about analyzing stream health from Monteverde. And so today I'll be talking about the findings that I've been able to evaluate about the 7 different streams that we've looked at and collected data on through the past 5 years since 2019 in Monteverde, through using RStudio and the R program language as well, like Ethan. And so Monteverde is this huge biodiversity hotspot. We have a lot of flora and fauna that's not found in other parts of the world. And so looking at the stream data also impacts these ecosystems, and this is also like the water that is used for the rest of the community for their own personal activities. And so looking at stream health can help not only community but the rest of the world as well understand the different effects of climate change and reforestation and how that's affecting just our water quality in general. We can look at environmental changes and just understand all the effects that's going on to water. It's so important to our community and our lives. So these are the 7 streams that I observed. We have Colegio, Cuecha Fábrica, Cuecha Reserva, La Saca, Máquina, Sucia Casa Arte, and Rio Negro. So these are the 7 that we looked at. And so the data set that I was provided with had 115 different entries and 19 variables. And so some of these columns were left empty, and had like missing values, so that's represented by our NAs here. You can see row 21. And so this wasn't too big of a deal, and we were able to fill in these missing values and still make good interpretations. All right, so my overall biggest question was, how did the various environmental factors given by our variables affect our streams, and just the biological water quality score, which is our BMWP score. And so that stands for the Biological Monitoring Working Party, and it's a score. And in our data set, we have values between 0 and 140 represented. And it assesses just the ecological quality of the water, and obviously the higher scores indicate that there is better water quality. So our initial insights, I looked at all the 7 different streams and what their score was. And it looks like over time we're seeing that it is getting better. So there are a lot of different initiatives going on in Monteverde, but overall our stream quality is getting better. 2 streams did stand out as Sucia Casa Arte and Colegio, who have moderately impacted scores from pollution and different just issues with the quality of their water, whether that be pollutants or turbidity. And overall, they're all getting a little better, not very quickly, but consistently over time. And so this is a correlation heat map, and it's something that I created in R, and it creates like a visual picture of what are the most important variables when we're looking at our score. So this is going to be our score column over here, and the dark blue is going to create, it's going to show that there's a positive association between the different variables, and then the dark red is going to be a negative association. And the darker, or like more potent, I guess, the color is, the more association it has. So we want to stay away from the lighter colors that might not be able to tell us as much about whether a stream will have a good score or not. So our top predictors were num-fam, which is the number of different families of intervertebrates or macrovertebrates within a stream. And so this makes a lot of sense because obviously these macrovertebrates need a good environment in order to survive and flourish, and they need an environment that's able to fit all of their needs. And then conductivity was also another, it was a negative correlation factor. So with an increase in conductivity, which is the ions available within the stream, and this is coming usually from rocks or runoff, or sometimes from like human interests like agriculture or waste within the streams, it gets lower. And so those are our top 2 that we can use to help predict whether there's going to be good quality water or not. So multiple linear regression is one of the models that we ran in order to see just the bigger picture about how all the variables impact how we can assess what score a stream would have. And so it also can help us figure out what like missing values could be estimated given the other values that we found in our data sets, and some of them were blank. And we have a very high score of 0.9308 for the adjusted R squared, and that basically means that we can predict for about 93% of the variance in all the scores just given the data and the variables that we were provided. And so then we tested this model, it's like a machine learning model, to observe whether it is actually predicting well. And so the closer that these dots are to the line, the better the model is in itself. And it seems to be doing fairly well with prediction, which means that we can end up applying it to further and like future work with predicting how a stream would go, especially with factors like climate change. If we're gathering more data on our significant variables like the conductivity and the number of macroinvertebrates within the water, we can see whether the score would go down or not. And so obviously the biggest finding is that biodiversity is very important to the overall quality of streams, and it's huge. Biodiversity helps with just maintaining good relations between all the different organisms, so that if there is some sort of event that messes up a stream, some will be able to survive and continue. And also just all the different issues like algae and all that. And it also has a very high correlation. It is huge with predicting whether a stream is good or not. So a strong association. And so in context, all of this can really just help us with policy making and assessing all of the environmental efforts that have been put on through the Institute and other like organizations. And just looking at the long-term trends can help us like evaluate the success of all of these initiatives and just prepare for the future. I mean, we have a lot of pollutants, and there's a lot of issues with climate change and reforestation. And all of that together can be hard to assess what is being successful or not. So this will help us just prepare for the future without having to always be collecting data. So moving forward, I think that we should collect more data on the differences between dry and rainy seasons and other hydrological variables about these streams, like the depth and the volume. And then for these species, since biodiversity is so important, maybe just differentiating between what species were captured, making sure that that's also provided in the data set, so that we can see whether certain species are surviving or not, and what species are most important to maintain within the streams. So that's all. Do you have any questions? If you have any questions, let me know. That's fine too.
Great job. Thank you so much. So to see if I understood the things of the observed versus the predicted was for conductivity and number of parameters? Or?
It was for our overall entire model. So the whole line was for like our observed like values of the score and the predictions of it, based off of the ones that we had like complete cases for, and then the ones that we were guessing about for the other variables.
Okay, thank you.
Yeah.
Thank you.
Hello everyone, I'm Aiden, and today I'll be talking about Aqua floribunda, which is a type of avocado tree, and more specifically, the elevational survival shift it's going to go through due to climate change. So, my project had two main research questions. First, does this species of tree have a greater survival rate at higher elevation within their normal growing range? And second, does this tree have higher growth when planted at the higher elevations? And these questions are important because recent predictions from climate change have shown that this tree species will go further up the hill, like further up in elevation, and this could cause some potential problems. Sometimes the water quality is different, sometimes the soil quality is different, sometimes there's different like fauna up there. So it's important to know whether this shift will impact the health of these trees. So for the data, Debbie was nice enough to provide me 2,539 observations of trees across 6 different sites. There were 13 variables here. First one was the site, which site it was planted at, which species of tree is it, just the identification number of the tree, what elevation it was at, whether it was in the sun, whether it was partially covered, whether it was in the shade, what age the tree is, how tall the tree is when it was observed, how many leaves were on it, how was there damage, and if so, what % of the tree was damaged, what could have caused this damage, like when it was discovered, whether the tree's alive, and also the ID number to identify the tree. And you may notice that there are some missing values here for height, leaves, damage, and cause. That means that the tree is dead at that point in time, like it's not alive, is unable to be monitored in the future. So the data was collected across 6 different sites. For the site identifier, you've got the name of the site on the left, and you've got the year, like the trees were planted on the right. For example, Cran 16 right here is the Crandall Reserve, and these were planted in 2016. And these trees spans many elevations within the range of 240 meters. So we have a decent range of like, okay, what different elevations are there, how this could affect things. And we also have several observations. There are usually multiple for each tree because we're monitoring them over time. So you guys might be like 611 in the Carnegenie Reserve. In reality, it's like maybe 100. Okay, so for the first question, does O. floribunda have a greater survival rate at higher elevations? And the short answer is not really. So if you focus on like the lowest site, which is the Carnegenie Reserve, it's like, okay, they're all surviving at the beginning, you've got a few dropping by year 2, year 3, year 4. Unfortunately, by year 6, most of the trees are dead, up to 75%. I've seen a similar thing in the next highest elevation. And then, same with this one right here, it's like, with this one, there's a more noticeable shift, where I'm not entirely sure what the circumstances were behind this, but fortunately, not a single tree managed to survive on this one. But then as you keep increasing, you keep going down the heights. This one right here, the Crandall Reserve 16 is one of the higher elevations, and it looks, if you compare these ones, they're almost identical, despite the fact it's like the difference between this one and this one is maybe 20 meters. The difference between this one and this one is about 200 meters. So height doesn't really have an impact here. And to illustrate this, overall, there's not going to be a trend. If you look at them, they're all approximately the same survival probabilities. There were some sites that didn't fare so well, like the REFR 18 and REFR 17 sites. Most of the trees there, unfortunately, did not make it. But overall, there's no real trend here. There are statistical differences, like we've tested the hypothesis that these are the same. There are statistical differences between the pairs of survival curves, but overall there is no actual trend whether elevation has an effect or not. For the second one, does O. floribunda have higher growth when planted at higher elevations? So for this, look at the tree heights themselves, look at the difference between them to determine whether the growth rates were different, because fortunately we're monitoring them over time for instances. And one of the things which we did find is that elevation, again, has a negligible impact on growth. If you look at the estimate for elevation here, for each additional meter, like higher the tree was planted, it's estimated to be 0.008815 centimeters shorter, which if you focus on extreme differences, that might be 1 to 2 centimeters. And while that does sound like a sizable thing, for the trees to actually have survived, like for all 6 years or for 5 years, they're maybe 30, 35 centimeters tall, and will continue to grow. So it's like, yes, it's a small difference, but it's not going to have much of a big impact. And there's a strong correlation here, like a lot of the variation can be explained by these 4 variables. However, there is a caveat to this, because if you focus on leaves, for example, the leaves in this multiple linear regression, taller trees have more leaves. It's like if you're predicting the height of the tree from leaves, it's kind of redundant. So if you were to focus on the second model, without that, yes, the effective elevation is bigger, but also the correlation is much lower. Like you've got, instead of the 0.77 you saw earlier, instead it's like 0.18, which means it's like, yes, it might look like this is a big deal, but also it's like most of the correlation that we saw in this other model was actually caused by this leaves variable. So what we're seeing from here does not actually mean that much. It could be explained by random chance. And just to show how big of an effect the leaves variable had here, this one on the left has it included, where with these diagnostic plots, it's showing the predicted height on the y-axis and the actual measured height that people went out and actually measured the tree with on the x-axis. And one thing you might notice is in an ideal world, this would be following this line. So the one with the leaves included to try to predict the height is a lot more on the line. The predictions are a lot closer to the actual measurements. And this is again more leaves, probably a larger tree. And when you remove it, it's yes, it might start out normal, but as you keep going to the higher heights, like the trees that are taller or even that are minimally tall, the predictions become more and more off. So there's not really a noticeable trend that we are able to determine with this data. And in the future, one of the things which could be interesting for me or whoever picks this up after me to do would be to actually incorporate different types of predictors for the height using initial data. One thing that could be very interesting to look at is, okay, it might not be the elevation itself, but it could be, if we pull in weather data, for example, it could be that some places receive a lot more rainfall than others. Maybe the type of soil is different. So it could be very interesting to look at that and see if that's a better predictor for tree growth, survival rates, than say elevation. Another thing that could be interesting, but might not be feasible, would be examining a few more sites to see if we can get a bit more accurate picture of the trends that we've been observing. It's right now there might not be any correlation, but maybe it could be what if those two higher elevation sites that we saw could have been just not so much a fluke, but just could have been outliers instead of what's really going on. Could have been interesting to look at that. Another thing to look at is how other factors are impacted by elevation, which we may have seen. We may have seen that okay, height isn't very impacted, survival rates isn't very impacted, but could have the effect of okay, maybe there's more sunlight up there, maybe the air is drier, maybe that causes the amount of leaves to be different. It could be interesting to look at that. And finally, maybe fitting some additional models could provide more insights into this. Because what I used here was multiple linear regression, but we could also use machine learning models to see if that can determine trends. Thank you very much. Any questions? Sure.
First, thank you. That's huge. It's been one of these projects that's been ongoing, so to get answers is really good. And that it's not moving up in some ways it does make a difference. I don't know if that's good news or not good news, but what I was going to say was, I forgot what I was going to say. But it would be really interesting, one, to pick a species that has a good survival rate, which that would be another kind of interesting thing for anybody that picks it up, where they have such a low survival rate that it becomes hard.
Yeah. All right, well, thank you guys. Gracias. Thanks.
All right. Awesome. Hey guys. So my name is Wesley Kane, and I looked at the carbon sequestration of reforested areas. So just a bit of background. So since the kind of beginning of the Industrial Revolution, human activity has raised the carbon dioxide or CO2 levels by 50% worldwide in the atmosphere. And this increase accounts for 66% of global warming in the world. So trees are what are known as carbon sinks because they're able to absorb carbon dioxide and they store it as carbon. So the CO2 goes in, it releases oxygen as a byproduct, and it stores the carbon in the trees. And they're very important in reducing climate change because they're taking this carbon dioxide out of the atmosphere and storing them in the trees. 45% of the carbon stored on land is in trees. So just showing, this is the increase over time in carbon dioxide, and this diagram shows CO2 going into trees and it's stored as carbon. So reforesting pastures and plantations is one way that we can fight against climate change. So my question is, how does carbon sequestered from planted trees in a 4-year-old reforested area compared to the carbon that is sequestered from planted trees in a 16-year-old forest area? So the amount of carbon that's in the trees. So the study locations, I had 2 main study locations that I collected data from. The first was Crandall Reserve. It's right back out here. And it was planted 16 years ago, but I also have data that was measured 5 years ago. Finca Rodriguez is down the mountain past Santa Elena a little bit, and it was planted 4 years ago during the pandemic. Both properties had either been used for agriculture or cattle grazing prior to the study. I believe that Finca Rodriguez was used for as a coffee plantation, and Crandall here was used as cattle grazing. So methodology, in order to calculate the carbon stored in our plots, we needed to measure the DBH, which is the diameter of the tree at breast height. So it's around 1.3 meters high. We needed to measure the tree height, and we did this for smaller trees with a tape measure. And for larger trees, we used a tool called a clinometer. And we also collected data on general tree health, including leaf count and damage for future analysis. So I didn't incorporate those metrics into my study, but hopefully they'll be useful down the line for somebody else. So my methodology for analysis is we use the average of 6 carbon sequestration formulas with height, diameter, breast height, and average wood density in order to calculate the carbon that was stored in each tree. And we then multiplied the carbon in each tree by a constant of 1.235 to get an estimate of the carbon storage in the tree, including the roots. And we extrapolated these samples to the entire plot because we didn't have time to sample the entire plot, so we extrapolated to the entire plot. And also extrapolated to calculate the total amount of carbon in hectares, which is the standard in the industry for measuring CO2 reduction in carbon storage. And we compared our results in the different sites. So this is the data that we collected. So REFR stands for Finca Rodriguez. And then we have Crandall, which was collected when the trees were 11 years old, and the Crandall Reserve when they were collected now at 16 years old. So Finca Rodriguez has 700 trees. We sampled 142 of those trees. The average carbon sequestered was, per tree, was 0.931 kilograms. So in each tree, this is including the roots, they had 0.931 kilograms of carbon stored in them. The total this is the entire plot. So if we extrapolate with our sample size, the Finca Rodriguez plot had 651 kilograms of carbon stored in it. And if we convert that into the amount of carbon per hectares, as the standard is in the scientific community, it would be 6,517 kilograms per hectare. You can see the similar ones for Crandall, so 189 trees and 6.38 kilograms. So these are 11-year-old trees, so you'd expect them to be sequestering more carbon per tree. And then when they were 16 years old, they are so presently they're sequestering 27.14 kilograms of carbon, and per hectare that's 51,000 kilograms around per hectare. So if we look at the average sequestered carbon in kilograms annually per tree, the average, so going from 0 years to, so going from 0 years to 16 years, the average carbon sequestration per year is 1.689 kilograms. However, if we're looking at it from ages 11 to 16, there's a 3 times increase in the average carbon sequestration per tree per year. So basically what this means is going from 11 years to 16 years, the trees are sequestering carbon at a much faster rate. So before they're 11 years old, they're gaining carbon much slower. However, older trees are sequestering carbon much faster is what we're finding. So what does that mean? That's a bit confusing. So from when the trees are going from 4 years old to 11 years old, this is our 4-year-old plot and our 11-year-old plot, the carbon sequestered on average increased by around 27, this is percent, not times, sorry. It increased by 27% each year. And going from 11 to 16 years old, the carbon sequestered increased by around 76% each year on average. So this means that the trees in our study are beginning to exponentially increase in the amount of carbon sequestered at around 11 years old. So that's a really important marker. So calculating CO2 reduction per hectare. So what this means is this is calculating the amount of carbon dioxide that we are taking out of the atmosphere, which is an important metric in fighting and measuring climate change and our effects on helping fight that. So we multiply the carbon stored per hectare by 3.663, and that gives the CO2 reduction. So in Finca Rodriguez, the trees are much smaller presently. So the present amount in tons would be 26.31 tons per hectare, and this is in per hectares. But if you and the actual plots are only 1,000 square meters, so you would take 10% of the amount of tons, and that would be the total CO2 reduction in the actual plot, and I'll give that number later. But so at Crandall, which is 11 years old, the amount of CO2 removed from the atmosphere per hectare was 46.53 tons, and in Crandall, the amount of CO2 removed from the atmosphere per hectare was 207.1 tons. So average biomass analysis. So the biomass that's stored in a carbon sequestering tree is around 50% of the dry weight, which is also 50% of the weight. So it's around 25%, but this varies based on the area that you're in and the specific tree species that you're using. So these graphs show the tree species name. So these are all names. So this is Inca pontuta, and it's a nitrogen-fixing tree. And we found that it stored a lot of carbon on average compared to other trees. And this is a trend that will be explained by my colleague Firdaus in a future presentation, right there. But overall, this is just the average biomass of carbon that was found in each tree in both of the sites. So you can see that in Crandall, the average carbon was much higher than in Finca Rodriguez, because Finca Rodriguez is much younger. And so why is this significant? So in the fight against climate change, reforesting areas to create carbon sinks is very important. The results of the study show that this process takes time. Trees don't sequester a lot of carbon overnight. Until it takes around 11 years for it to start in really any significant capacity. And organizations conducting reforesting operations should consider this when they're trying to calculate the impact of their work. So the reforestation efforts by the Fundación Conservacionista Costarricense and the MVI are having a very significant impact. Between the two sites, the planted trees have removed around 20 tons of CO2 from the atmosphere, and this number is going to more than double. It's probably going to quadruple once the Finca Rodriguez trees mature, because there's over 700 trees in that site, and they're all really young right now. So it's a really promising start, but if we really want to reduce the amount of CO2 in the atmosphere, these reforestation practices need to be adopted on a much larger scale and in many more communities. But it's a really good start, and I'm very happy with it. So thank you so much to Lorenzo, Vida, and Isabella. They've been very amazing. And when I had to wake up and go to the sites at 5 a.m., Vida was amazing and woke up and helped get me food. Thank you so much to Verdas for helping me measure on site. And thank you so much to Deborah. She's been amazing and helped me so much in things I don't understand. And she's great. Thank you so much.
Yeah.
Oh yeah. Any questions? Sorry. Oops.
Awesome job.
Thank you.
Awesome job. Who planted the site at Finca Rodriguez, the 700 trees?
Lorenzo.
Lorenzo raises all of those trees.
Yes, Lorenzo is amazing. My host father. He cares for the trees. He does maintenance. He planted so many of them. He's amazing.
He is.
Yes.
He's absolutely amazing. Who planted them?
Oh yeah. The Monteverde Institute planted them.
Literally.
Yeah.
The staff.
Yes, the staff planted them, and in 15 years, those trees are literally going to be stopping global warming. So it's amazing.
So is it in community members?
Yes, the local community.
The pandemic.
Yes.
Who planted at Finca Rodriguez?
Finca Rodriguez.
Crandall.
Crandall was
This one up here.
you, and oh, we did. Mellon? No.
Sophia.
Oh, Sophia. Oh, you did. That's awesome.
I did tell them.
Oh, yes.
How do you estimate the carbon that's from the roots?
It's a constant average, and it's 23.5%. So we add on 23.5%, and that's just an average in the area. It varies by tree, but taking the average is much easier. Yeah. Anyone else? Awesome.
Hi, I'm Brenda, and this is Ella, and we analyze the recolonization of birds in reforested areas. So for context, there are a lot of reforestation efforts in Costa Rica led by NBI and FCC, and in order for forests to be fully restored, they need to support the same biodiversity as older forests. So analyzing birds are a good indicator of forest health because of their health, their diet, and habitat needs. And these are the two sites that we analyzed, which is Rufio Ecological Finca Rodriguez and Crandall Reserve, and these are the years of the forest. And our initial questions were, number one, what is the diversity of bird species populating reforested areas compared to older forests? And number two, if there is a significant difference in diversity, what habitat factors are influencing the bird species that occupy different ages of forest?
Yeah, so for methods to first collect bird diversity data, we use standard mist net techniques for 3 mornings per site. And we place nets both in the mature secondary forest, which is the older forest, and also the new reforested forest of various ages, as you can see here. We had to stop after the 13th at Crandall because of weather issues, so we went forth with just analyzing the 3 days at Carnegenie. For bird processing, we looked at a variety of things when we captured each bird, including where we caught it, what species it was, and then a variety of other factors that would later help us identify why the birds were there, how long they were staying, and what their breeding patterns were. For forage availability, we walked the length of each net and looked off into the forest and recorded all visible fruits and flowers as well as their quantities, which were estimated. This was a very brief look of each site. And then nearby nets were grouped together for a larger investigation area. Some things we looked at were the forest age, whether it's a fruit, flower, or seed, and then we used the size in centimeters and the integer amount to calculate the total fruit available for each type of fruit.
And these are the results that we got from Finca Rodriguez, and we analyzed the diversity of bird species in old forest and reforested areas. And we analyzed the captures per day per forest type, standardized by mistnet hours, which is that top graph right there. And then we also analyzed the recaptures of birds, and we found out that in the old forest, it's actually 50% new birds and 50% recaptures, whereas in the restored forest, there are actually more new birds compared to recaptures. And these recaptured birds shows us that birds are coming back to the forest, so they are staying in the forest. And then for breeding status, we analyzed the brood patch of the birds, and we found out that 64% of the birds had a brood patch, which shows that they are reproducing and staying in the forest. And we did a Shannon Diversity Index to characterize the species diversity, and we found that species in the restored forest are more diverse than the old forest. And then we took that Shannon diversity and we did a special t-test, and we found out that the species of birds in the reforested areas are significantly more diverse than the old forest. And then we also did a Bray-Curtis dissimilarity test, and we found out that the species in the two forests are 80% dissimilar, which meant that only 20% of the species were similar. And we also did a chi-square test to compare the observed and the expected results of the individuals per guild, and we found that there is no statistical difference.
Right, so we found out that there is a dissimilarity in between the old and restored forests, and so our second step was to find out why. And so we examined forage availability and wanted to know did the amount of seeds, fruits, and flowers in each study area affect which bird guilds we captured? So here in this chart, you can see the distribution of seeds, fruits, and flowers per net. And then we can visualize that in the old and restored forests. Because there was majority of flower availability in the old forest, we anticipated that if the two were, if that was directly correlated to the guilds, that we would find a lot of nectarivores, but that was actually not the case. So we found mostly frugivores in the old forest, and we think that's because of the different types of flowers that were available. Because in the restored forest, we found a lot of flowers that we knew were attracting hummingbirds to the forest. But in the old forest, the flowers, we didn't find any of those flowers of the Carnegenie family, and we found smaller flowers that may not be attracting birds. So the next step would be to specify which flowers are being recorded and whether those specific species do affect the birds. We then ran a series of linear regression tests to figure out whether the availability of different foraging was correlated to the amount of birds we found of that guild. So this first one is frugivores versus fruit availability, and we found that in the old and restored forest there was not a significant correlation. The same went for seed eaters and seed availability. We found that there was no correlation in either the old or restored forest. In the nectarivores and flower availability, however, in the old forest, since we didn't catch any nectarivores, we couldn't determine this. But in the restored forest, we found a pretty significant correlation. Although the p-value is still a bit too high, we think that compared to our other data, that this is worth looking into further. Yeah, so in conclusion, the recolonization and use of restored forest appears to be successful. Other than the flowers and nectarivores, the possible relationship we found between them, the foraging availability alone is not a significant indicator of what bird species we'll find there. And then for further investigation, since habitat is more than just foraging availability, and it's also forest structure, like what kind of nests the birds are making in it, and also reproduction areas, we think that a more thorough research collection should be conducted to have a more holistic understanding of the habitat and how that is correlated to the bird guilds.
We would like to acknowledge Debbie for leading this study and other people who helped us with the bird nest netting process, like Lisa and our tropical ecology teacher, Sophia, and the Monteverde Institute, Carnegie Mellon, and the birds in Monteverde. Questions?
What's the coolest bird that you caught?
I think the coolest bird that we caught was actually the mott. It's in that picture right there. That's it.
Yeah, I thought the mott was cool too, but I was unfortunately not there for that. But I really actually like this guy right here. It was a really a smaller bird, and it liked to hold on to my thumb with its claws, and I thought that was really cute.
Of course, I have a question. Awesome job, super cool. It's been really fun to have you guys out. Miss Netting, and I hope tomorrow you'll come out too. What do you think about the fact that your species were not similar at all, but when you put them into guilds, there was no significant difference between the old and the restored?
I think that means that there's something else going on. That is not about what they're eating necessarily. We did some preliminary research before this study, and a lot of other research that was carried out also heavily investigated the different types of nests that could be made in the forest. So I think that would be interesting to do in order to further study this. Thank you.
Hi everyone, my name is Alive, and in this project I collaborated with my colleague Wesley. She is not here now, but you listened to his presentation. And while he was looking at the carbon sequestration, I was particularly interested in exploring the influence of Inga punctuata, or a nitrogen-fixing tree, on the survival and growth of surrounding trees. So, for some background information, the survival and growth of trees are influenced by lots of factors, such as the quality of soil, weather, temperature, climate conditions, or interactions with surrounding vegetation. Among these, nitrogen-fixing trees, which enhance soil fertility by converting atmospheric nitrogen into a form usable by plants, by other types of plants, present an interesting area of study. So this research aims to explore whether the presence of a nitrogen-fixing tree, Inga punctata, can positively impact the growth and survival of neighboring trees in Monteverde forests. So why Inga punctata? So as Wesley mentioned it in his presentation, Ingas have one of the highest indicator in storing carbon sequestration. So it was very interesting to look at this type of tree when it comes to studying the effect of nitrogen-fixing trees on other plants. So nitrogen-fixing plants host rhizobia bacteria on their roots, which convert atmospheric nitrogen into nitrogen compounds that the plants can use. So specifically, they transform ammonium, which is not readily usable by most plants, into nitrate, a more accessible form of nitrogen. And although nitrogen-fixing trees, including Inga punctata, mainly utilize nitrogen for their own growth, they may also provide benefits to surrounding vegetation that this research focused on. So in our study, we considered 3 factors as the indicators of tree survival and growth, which are existence of the tree. If we particularly look at if the tree is alive, so if it's not, we just indicated Na, which means that unfortunately the tree is dead already. And the height of the tree together with the volume of the tree. And our study location, my study location, was Finca Rodriguez, because in Finca Rodriguez most of the plants were planted 4 years ago together with Inga punctata, so it was really interesting to look at the recently planted Inga punctatas, their effect on the other types of plants. Our methodology, as I mentioned, I worked with Wesley in this project, and in particular Wesley was responsible for all the measurement work, and my responsibility was only inputting all the data in the data sheets. So first we got the data for trees that are within 2 meters to Inga punctata and those that aren't. So we basically divided the plants into 2 categories that are within 2 meters with Inga punctata and which are not. We measured the height, measured the DBH, which stands for diameter of the tree at the breast height, calculating volume by using the formula pi r squared times h, calculating standard deviation, and we use it to sample t-test to check if there is a statistically significant difference between these 2 types of trees, which are near Inga and which are far from Inga. Also, and while working with the trees, to avoid the third variable, the possible third variable problem, we excluded the trees that were planted in shaded regions because obviously the sunlight could be one of the third variables that would lead us to mistaken results. So we included only the trees that were planted in open areas and had direct access to sunlight. Also, we used the drip line method, which means that we assumed that the roots of Inga punctatas can reach the distance that their branches reach. So we considered the distance between a particular tree and the branches and the nearest branch of Inga punctata. Also, for very tall trees, we used an equipment called clinometer. And so basically, it helped us to measure the height of super tall trees by using some trigonometry. We basically were in distance 10 meters from the tree, and we looked at this through the lens of this equipment. We identified the number at the base and the number at the top of the tree, added the values, and multiplied by 10 to get the height of the tree estimation in centimeters. So, results. We focused on 5 types of trees that were planted near Inga punctata and that were also planted far from this tree. And the first one was Mauria heterophylla, or just Mahe. And according to our 2 sample t-test, two-sample t-test, the significance level at the significance level 0.05, the p-value was 0.1714, and as p-value is greater than the significance level, the null hypothesis, which says that there is a significant difference between these two types of trees, couldn't be rejected, meaning that we couldn't find any significant statistical difference in Aurea heterophylla. And I would like to pay attention to the number of trees that were planted within 2 meters and not within 2 meters. So Y11 stands for within 2 meters trees, and X21, the number of trees that were not planted within 2 meters. And our next tree was Damburnea salicina, or previously known as Nessa. So according to our test, again, the p-value was greater than the significance level, which means that we couldn't find any significant statistical difference in this tree as well. And again, in this type of tree, we could find 9 trees that were near Inga and 26 that were far from Inga. And we also considered that these numbers could affect our results as well. Next tree was Ocotea monteverdensis, or just Ocmo. And in this tree, p-value was also greater than significance level, and there wasn't any significant statistical difference. And the difference between the two types of trees, number of two types of trees, were even more significant, 11 and 44. Next one was Sideroxylon portoricens, and in this type of tree we had the equal numbers of trees from both types, 12. But again, the p-value was greater than significance level, meaning that there wasn't any significant statistical difference, which also works for the STPE, or Stauranthus perforatus. So again, the significance level was less than p-value, meaning that there wasn't any significant statistical difference. So for all the types of trees, 5 types of trees, we couldn't find any significant statistical difference according to our results. So, which means that Inga punctata, the recently nearly planted Inga punctata, didn't have a significant effect in the survival and growth of other types of plants. But it's worth to consider the fact that there were differences in the number of trees in both types, so in Y and X's. So we also should consider that this difference could affect the final results. Also, despite all species, including the Inga trees, being planted simultaneously 4 years ago, it's possible that the Inga trees are utilizing a significant portion of the available nitrogen for their own growth. So we can assume that as they were newly planted 4 years ago, maybe Inga punctatas using the nitrogen that they are absorbing for their own benefit, for their own growth. And maybe that's why we couldn't find any significant statistical difference. But it's worth to continue this research, and there is a motive to do further research, looking at the trees that are planted near already mature Inga punctatas to test if our hypothesis is true and mature already grown Inga punctatas have any effect on the survival and growth of surrounding trees. Yes. Any questions? Yes.
I don't have a question, but that was great. I would have loved to have seen a relationship, and I think you're right, we need bigger samples, and we need to set up an experiment just to do this, but it's also showing with 5 species, we're not seeing anything,
Yes.
but thank you for doing that.
Yeah, thank you too. Thank you for your assistance. You helped a lot. You explained everything that I had no idea about what I was working at the beginning, but thanks to that, yeah, it's all clear now. Thank you.
for those of you who don't know me, my name is Hernandez, and I did my project and analysis on the reforestation efforts of the Monteverde Institute and the FCC. So this is history that many of you already know, but for those of you that don't, back in the 1940s and before the 1940s, forest covered 75 to 85% of the entirety of Costa Rica. But by 1970, about 40% of that had been cut down to make way for dairy farming. And so in the late 1990s, there was a big effort to restart the reforestation and bring back all of those forests that were lost. So with the efforts of the government, the FCC, the Monteverde Institute, and other individuals, now in 2017, we've gotten back up to around 52% of Costa Rica's landmass covered by forest. The Monteverde Institute has, by itself, planted 250,000 trees since the founding of the Institute in 1998, and each year they are planting an additional almost 15,000 trees each year. But obviously not every tree that is planted will survive, and not every tree that survives is equally important to the ecosystem. So in order to measure what forests are successful, we are using the help of our little friends, the birds. This right here is the mont that was captured in their presentation earlier as well. This is his head that you couldn't see earlier, but beautiful guy. But since species of birds have their preferences of their own habitats and their different types of foods, we can use these birds as markers of a forest success. So the research questions that I sought to answer were, what birds are living in these older forests versus the newer forests, and what is the diversity of species and the functional role of each of these species throughout the forests. So overall, we had about 500 entries in my data. My data was taken from the month of October in 2023. And of those over 500 birds, about 2/3 of them prefer forested areas. This is the habitat F here. That's for forested areas. A little over 1/4 of them preferred edge type areas, which is right between forest and kind of open plains. And only about 12 were birds that preferred to live in these more open areas. So since my data was taken from October 2023, in October it's a time of year where there's a lot of neotropical migrant birds, so that's something that's unique from my data as opposed to the data that was collected by my colleagues and theirs. And of these birds, throughout the month of October, the bottom axis here is going to be showing over time, so each of these bars is going to be a single day of data that's collected. And the blue is going to show which of those birds that were collected enjoy being in forested type areas versus the other types of areas such as edge or open fields. And then this is a closer look splitting up the data into those older forests on the left and into the reforested forests on the right. There seems to be in this a pretty similar amount of forest preferring birds. However, there's a lot more birds that are preferential to the edge type habitat in the reforested forest, which makes sense as it's a lot newer and less abundant. And then there's also a couple of the field type birds that were found in the reforested forest as opposed to the original ones. And there was a very statistically significant difference between these two areas as shown by the chi-squared value. It starts becoming significant at a value of about 8 for this one, and it becomes like, it's more significant the larger the value, so a value of 250 is highly significant here. Similarly, this graph, instead of splitting it up by the habitat type, it's going to show it by a guild. And a guild is basically what role does it play in the ecosystem and what does it eat. So in both of them, there is the most of the insectivores, which eat insects, then secondly frugivores, which eat fruit, and then kind of dropping off, getting to the seed eaters and the nectarivores. And there was not really any super omnivorous birds in the ones we found. Similarly, it was very statistically significant in the difference between the two. But these graphs that I've shown so far here are just showing the kind of the count of each of the bird types, so getting a more proportional version towards the that it factors in the number of mist netting hours is going to be shown on the right here now. So you can see when it's factored in, there's a lot. It's a lot more similar towards the amount of insectivores that were found here. However, the proportional amount of frugivores is a lot higher in the older forests as opposed to the reforested forests. And then similarly, you can see when factoring in for the habitat types, then we get, it's a little more balanced. It's not as different for the habitat types, but it's a little more balanced, and you can see that there's a lot of birds that solely prefer forests in the old forests, and there's a bit less of those in the reforested forests and a bit more of those hedge type birds. So that's what I was able to take out of that data so far, and some future work that would be important to be done, and part of it that was already done by my colleagues here, Ella and Brenda, is to see which reforested locations are the most similar to these older forests, seeing how well they're doing, and to attempt to improve the locations that are the most dissimilar to the original forests. And then lastly, to add correlations between those bird types and the forest structure and the types of food that can be found in those forests with their forage potential. And that's all I have. Gracias.
¿Preguntas?
Was your test between the different gill types within the habitat, or were they between the two?
So the tests were between the old forest and the new forest. It was not
So
between.
it was a composition.
Yes.
Okay. Cool.
Yes.
Thank you, very interesting. I have one question, but I want to clarify too, that the 250,000 trees is definitely not just the Institute effort. Actually, most of those were planted by FCC in the years leading up to when it became a formally collaborative effort. And I thank Deb especially, who is an incredible leader in reforestation. I'm curious what you think, or what observations you made about the surrounding landscape around your two sites, and if you think that can have an influence, like if there are birds visiting the areas that you actually mist-netted, that could be coming from open areas or from more forested areas that might influence the community composition that you saw.
So that's a great question. Thank you so much for the clarification. I appreciate it. And additionally, I do want to note that when I'm talking about old forest versus new forest here, this data is a little bit more robust. It was not taken from one site. It was taken from Calandria, Crandall, Finca Rodriguez, and a bunch of these, and I kind of aggregated it into just talking about the old versus the new forest to not be too busy or too many columns that are kind of harder to compare visually. And because of that, I would say it's a little bit hard to answer the question that you asked. I spent a little bit of time, definitely obviously in Crandall, and also I think we went to Finca Rodriguez one time, but I haven't been able to spend too much time in each of those to properly answer your question. I would like to do more work to look into that.
No, but I think by having those multiple sites with that same difference, it would help to account for any differences in the surrounding landscape and really attribute it more to that factor.
Yeah, that should not be as much of a factor.
Yeah, very interesting.
Cool. Thank you. Oh, Tatum?
No, I was getting ready to clap.
Okay.
Did the video download?
I'm gonna unplug this video and so you guys can see that.
We're having technical difficulties earlier. Both have, so we're gonna hope it works.
No, the technicals are fine.
It is not
lots of statistical information before, so it's also a good time for you guys to take a little break and then we'll get started.
No, it'll be like 30 seconds. Don't worry.
Yeah, a few seconds.
Okay. So when you want to see the video, you click on this little icon.
Okay.
I guess I could plug this back.
Do you know if the sound works okay?
Oh, it should be.
We'll find out.
Yeah, we'll
Is it up?
Okay, good, thank you. Okay, this is you need
Hi everyone, I'm Maria.
My name is Tatum. And for our project, we did Luck and Legacy in Monteverde, the story of Lucia Lucky Gwendon, who we have the wonderful pleasure of having here today. Sorry to put you on the spot. And yeah. So what got us started on this project is we really wanted to do something based in the community. Just from being here like a week or two before we started, I feel like we learned so much about the rich history and all of the love and stories shared within Monteverde. So we wanted to give back somehow. And so one of the projects going on here in creation was the creation of a live book of Monteverde's history and to preserve the stories of the community for future generations. So currently there is this book, you want to hold it up? It's the Monteverde Jubilee Family Album, which Lucky was on the committee for creating, and she told us that she typed all of these pages up that people sent in to her. And another current resource that's out there is some videos on, I believe they're on the Monteverde Institute's website in their digital archive of some oral histories for people that want to listen to it, and hopefully in the future they're thinking of producing a podcast of people's stories here. So that those in the community and those that come after them can hear about what's come before them. And so our role in this project was to interview Lucky, which we did over a 2-day span. And Lucky first arrived in Monteverde in 1950, moved here first in 1951 at the age of 18 with 6 other Quaker families. You all might know of more or less of the Quaker history, but we wanted to highlight that since then she's become a cornerstone of the community and has seen the region grow and transform. And so I won't speak all of it for you, I'll let Lucky say some of it for herself. And I'll let you see a sneak peek of what we're trying to create with these live stories. And apologies, I wish it had subtitles in Spanish as well, but that's another hope for the future. So apologies if anything is hard to hear.
Is it audible? I guess not.
I think you should put it
Like all the way up if you can. Okay, I'm gonna start it over one more time.
Well, I was born and raised in Iowa, small cousin who was a year older than I was, but we played together. We lived half a mile apart. So I went to Ohio to a Quaker boarding school called Albany. That was where we became engaged when I graduated, because he was two grades ahead of me. So, but we wrote, and this I hardly can even believe myself. We wrote letters every day, but then when it came to the first peacetime draft, 1948, of the U.S. My husband, along with 3 others in their meeting, decided to not register in the draft, even though there was, you could register as a conscientious objector, CO, they would call it. This was in protest of it being that law, and so they were sentenced to a year and a day in prison. But when the judge sentenced them, he said, well, if you can't follow the laws of this country, you should look for another country. So that planted the seed. Anyways, they got to Costa Rica, and they had just abolished their army. And so they were very proud, they said they had, very proud of the fact they had more teachers than soldiers. It took 6 months of looking, just almost 6 months of looking in various places. Either they were too hot, or they were too wet, or it was too windy, too something or other. So we didn't actually move up here until December of 51. On this part, there was no spring, no water, and just trees. So the first thing my husband did was to dig a well by hand. I'm not sure about it. We just couldn't, everything's going to be new, so you took things in your stride, you just do, you try to adapt to it. Well, our first year here, in 51, 52, we were living in somebody else's tent beside the river across from Dorothy Rockwell's house. And so we started square dance. And it was caught on very well. And many Costa Ricans came to square dance. In the early 70s, is when 2 artists came to live in the community. They lived here for 10 years. They were at that time were nature artists, pretty much so. And well, I'd always drawn. I would always draw these names since I was little. But their belief was that everybody could be an artist. Anybody. And so they did not teach how to do things. They taught us just to see. It wasn't until much later that I started with pen and ink. Is when somebody gave me their paragraph pens. I think of them as kind of like my children, you know, I never look and see what my name is. That one. The big one behind, right behind you.
This one?
Yeah, she did for my husband, for her father for Christmas one year. And the other, the top left, was inside a pine tree, so she was sat inside the tree. For several days she even slept inside the tree. It was in the woods. So she's up there doing it.
I hope you all enjoyed the short video. A little more background on the video is like we were able to conduct the interview over 2 days with Lucky, and the actual video is like around 2.5 hour long. So we're still editing it, and hopefully we'll be able to upload the video on YouTube on the Monteverdi Institute channel, and you'll all be able to see the full version of the video if you want to. And the other future possibilities we are hoping to do is like interview and preserve the stories of other community members who were also like part of the community from the very beginning, and share the stories with the next generations and other people. And the last one, that not last but least, we were hoping to continue this project with the future interns and preserve all these stories and information as a digital archive. And as you saw like in the video, like there wasn't any Spanish subtitle, the interview was in English, but for the big video, we are hoping to add the Spanish subtitles so it can be shared with anyone like in the world or like outside of the Monteverdi community, as well as the Spanish speaking community too. So, and we also want to thank Lucky, of course, and Angel and Irene for sharing their experience and expertise with us to continue this project. Although we really hope that we had much more time to continue this project, but we're glad that we learned a lot about the history of the community, as well as like how it transformed over the time. And we really hope that the project will be continued in future. So thank you, everyone. Anyone have any questions?
So I know you guys like prepared some questions before like doing the interview. After working with Lucky and doing the whole process, are there like some questions that you picked out that you feel like are really important to continue to ask in this project?
That is a good question. I feel like for any interview that's just asking them to share like their life story, if you have the basic things of how did you grow up, what was maybe your early years like, what were your late years like, how did you get to where you are now, the conversation kind of ebbs and flows. But one thing that definitely helped me with this interview was like reading the book a little bit about Lucky, because that's when I first found out like she's 18 when she first moved here. Like that was a big conversation point. I was kind of just curious. I wanted to know what it would be like. So yeah, it flows.
Yeah, and to add on to that, I think like when you have the main point of this interviews are to interview the people who were here like from the beginning or like early years. So I think those people, the stories are more about their early lifestyles, like before they came here, those time, and also after they came here, and their favorite memories. So like outlining those time frames really helped a lot with all the interview questions. So I think it will be very similar to the next interviews too.
What qualifies someone to be a part of the Live History?
I feel like I don't know enough to say that. That's very much guided by Enable and
Yeah, I think anybody, if you want to answer.
Sure. I guess at this point we're trying to do for elders in general and for people who are over a certain age. In the case of Lucky, we started and there were a couple of reasons. One of them was out of the Quaker community, out of the original Quaker community, there are only two ladies that live here in town. One of them is Lucky and the other one is Maria Lucky. So we really wanted to take advantage of that opportunity to interview that. It's not restricted to the Quaker community. The idea is to extend that to the Costa Rican community, and we have a number of elders as well. But it's more like an age type of thing, and also the conditions to make sure that we can have this person talking and sharing all their lives. Yeah.
Hello everyone, I'm Hugh Freeman, and I took a different approach from the rest of the presentations a bit, because I was re-envisioning Santa Elena's downtown through a twofold examination, which included statistical analysis of car data and also the analysis of response data, more qualitative data. So to start with the backgrounds, Santa Elena, as you all may know, has a population of several thousands, like local residents. But every year they take in hundreds of thousands of visitors, and the town's local economy is resides on this the tourism, because about 80% of the local space downtown caters to tourists. Despite this, downtown has a couple of distinct issues. For instance, during the high season, which we are not in right now, during the high season, traffic can become very bad, and there can be traffic jams for up to an hour throughout the center of Santa Elena. And kind of what exacerbates this problem is the disorganization of things such as bus schedules, cargo delivery, and taxi services, which all idle along the streets, which is A, bad for the environment, and B, it's just bad for the overall town's image. So basically, through Monteverde and also Corclima, which is a local group that is big on helping the environment through things such as reducing emissions, we have looked out for ways to redesign the downtown. So Corclima is submitting a proposal to the town of shutting down one of the main roads of the Santa Elena Triangle, which would be this boulevard. So they'd be shutting down this road. And where I come in is I need to analyze this data to see how the car data would be affected possibly by the shutting down of one road, and see how the other road networks around here could take on the extra traffic. So there are 4 roads. This is Boulevard, this is Desde Canitas Bolivar, this is Via Alterna, and this is Calle Cruces Canitas. So I first started by utilizing the data that was given to me by Corclima and Monteverde. I would do things such as applying a heat map, which is a useful visual way to see when the different types of cars were most busy. And at the end here, I had a total of the amount of vehicles per hour. This is on March 28th, 2024, on the street Calle Canitas Boulevard. So as you can see, the most common types of vehicles are obviously things such as motorcycles, cars, and also there's a lot of buses. The most common times throughout the 4 roads where there's a peak amount of busyness is the hours of 1 p.m. to 2 p.m., 4 p.m., and also 5 p.m. After doing that, I decided to analyze the linear relationships between Boulevard and the 3 other roads surrounding it. This way we could see if there's any distinct relationship between how busy one road is and the other. And unsurprisingly, there is a pretty strong positive relationship between all 3. But this also means that if we were to shut down Boulevard, the other roads would all pitch in to alleviate the stress of traffic. And there would not be one singular road that would be adversely affected more than the others. After analyzing the road, I also did a data distribution on the different types of vehicles for every single day of the data and every single road. For example, this is the box plots for Boulevard on March 28th. And I used this mainly to analyze the vehículos de cargos, or delivery vehicles, because that is one of the easier things that the town of Santa Elena can regulate to alleviate pressure and traffic stress in the center of town. And what I found was that it was relatively normally distributed, which is bad because we would rather there be no vehicles de carga, because the hours that we analyzed were between 6 a.m. and 6 p.m. So perhaps they could do their cargo deliveries overnight, or we would rather them be using specific hours in the morning or early afternoon when it is less busy. The fact that it's normally distributed shows that there are vehicles, cargo vehicles, every single hour, and that is one thing we can immediately do to alleviate stress in the downtown area. After I analyzed the car data, I moved on to response data because Core Klima wants the input of tourists and residents of the town to see what they wanted to have in a new redesigned downtown. So they sent out a Google form in Spanish and English, which had a lot of questions, and these 4 questions were open-ended, which was of principal interest to me. So you guys can all read these questions. Sorry, I couldn't provide them in Spanish, but they ask things like, when you need to go to the town, into the center of Santa Elena, do you face any particular challenges? So my goal was to find a way to display this data into useful ways, because unlike numbers, it's hard to quantify things such as paragraph responses. So one of the first ideas I had was implementing things called word clouds. And what word clouds do is they take the most common small phrases and words in that are text processed in the response data, and they give back the most common observations. So the question up here was, what do you consider to be the principal problems in the center of Santa Elena? So there's a lot of things that people mentioned, such as there's exclusive recreation, there's busy streets, there's obstruction of the roads, and there's a lot of other stuff. I'm sure you guys can look at what you want to look at. One of the main issues with word clouds, however, is it only gives the frequency of responses and doesn't tell us whether a response is a positive or negative. For example, if you guys can see down here, recreation events. If I was able to look at it and analyze it, I could say, oh, maybe people would be saying a lack of recreation events. But there's no way for this to display only positive responses or only negative responses. So it takes a human to interpret this. That was one of the weak points of word clouds. So that was the next step that I wanted to do with the response data. I wanted to find a way to find the sentiment and to be able to classify negative responses and positive responses. And this kind of gets to where I am currently working on, because I'm over the next week or so, as I'm finishing up my time here, I'm going to start implementing a process called sentiment analysis, which is common in text processing. It takes a sentence and uses specific keywords to see whether the entire sentence has a positive connotation, negative connotation, or is neutral. In addition to that, I'm going to be planning to use I've started to include a process known as topic modeling into the response data. And what topic modeling is, it is unsupervised machine learning, which classifies different responses and classifies them into a certain number of select groups. So one of the weaknesses here are a lot of the answers are pretty similar, they just have different phrasing for it. But what the topic modeling would do is it would group the obstruction of the roads or the cargo trucks or just all the vehicles into one. We could see distinct separate problems, and it would be a good way to quantify the different problems that people have with the center of town. And then finally, I have some recommendations or stuff that I would do if I had more time in this internship in regards to finding more data and interpreting more data. One thing I noticed was that the average age of the respondents of this Google form indicates that the opinions of younger residents are not seen or heard. The average age of the residents was about 38 to 39, and the average age in the area is about 33. So we need more people like him. We need him to give his opinions. I really wonder what he wants in the center of town. Perhaps a playground, you know? So being able to hear everyone's voices is of like peak importance. Also, taking more traffic data would be useful. The traffic data on the 4 roads was taken on 2 days, March 28th and March 29th. If we were to maybe do a full week, so we could see the effects of the weekends versus the week, 1 week in the high season, 1 week in the low season, it would go a long way towards analyzing the flows of traffic throughout the year, not just during these 2 days. And then lastly, examining the additional roads that the closing of Boulevard will affect, such as the road that comes up behind Boulevard and comes out right next to Bar Amigos, if anyone knows that road. I'm not sure what it's called, I'm sorry. But yeah, that's about it. And I just want to say thank you and gracias. And I want to especially thank Anibal and Felicia for being such a big help for me during this time. And I really appreciate you guys. You guys give me an interesting thing to do. And I hope you will appreciate my findings when I send them to you. But yeah, that's about it. Any questions? Yes.
Does sentiment analysis differ at all between like Spanish and English? Is there like a dictionary,
So yeah, in Python there's different packages that you can use that can analyze Spanish text data and English text data. So one of the things I used was a package called NLT Corpus, which implemented a lot of stock words that would not be included in the things such as the word clouds, things such as and, no, like, a lot of the useless words to filter out, stuff like that. So there's also, similarly, a lot of Spanish text processing packages that could do things such as analyze the mood, because you just look at the words like no or I don't like, no me gusta, you know, that sort of thing. Yes.
Can you go back to the box plots?
Yes.
You said that was data from 1 day, from like 8 to 6, or what did you say?
It was, so there's 2 days and 4 roads, so I have 8 of these box plots, I just couldn't display them all. I just want to use an example from Boulevard on March 28th. So it has all the different types of vehicles, along with the sum of the total vehicles. It was accidentally knocked out some numbers on the side, sorry about that. But it just displays the spread. So obviously things such as electric cars, which are very uncommon, and things such as golf carts have not a great distribution because there's so few of them. But things such as the taxis, the bicycles, and the motorcycles and all that kind of thing.
So there was, like on that day, on March 28th in Boulevard, there were like 250 cars, just to see if I understand the y-axis. Like there's, you know, the cargo automobile.
Oh yeah, per hour, the average amount of cars that were accounted for going down that road was about 250. Yes, and the peak hours were a lot more than the lower hours because it is skewed up a bit, so yes. No problem. Any other questions? Yes?
Maybe as a newcomer, I don't remember if it's your first time in the area, but was there anything surprising you found in the closet data analysis that maybe you didn't think about as a newcomer, or something
something that really was kind of interesting to me was the, I'll pull it up, the exclusive recreation that was mentioned, because I live in Pittsburgh in the United States, and literally like half a mile from me, I have a huge park that I can go in any time of day for free. And something I noticed here is that a lot of the stuff is you have to pay for, and that is obviously great for growing the economy and helping the town, especially when you're asking tourists to pay. But for locals, it's hard for them to say, oh, I want to go on a walk, let me pay $30 to go up to the Curry Concha Reserve, for example. That was something that I definitely found interesting. So I think just being able to either maybe give discounts to residents or make the local areas free for residents, along with other similar actions, that would go a long way towards making the town not just focused to tourists, but also beneficial to residents as well. Yeah. Yes?
Thank you, and I just wanted to say that this project or something is still moving along, it's still a process.
Yeah.
Something larger that we're working together with Corpima, the municipality, and the institute. Something that shocked us, and I guess all of us. This is spent 2 days, 2 full days, 6 to 6, those were 12 hours, 8 stopping cars along in this. And knowing that there were over 2,000 vehicles crossing that downtown, it just changed a lot of the perception. You know, it's not that in a rural town you always stop. It's not. It's definitely not. It works just like you were in the middle of the city. And having that amount of cars or vehicles in general is just a lot. And so yeah, this process is trying to be as inclusive as possible. And this is just one survey out of a lot of other things that will take place, workshops and activities which actually the police is working with high school to hear more the voices of those who did participate in the survey. But this was actually a really good response. We got over 500 responses, I believe, just on that one. So there is a lot of interest, for better or worse, about downtown or what happens in downtown, which is good. And we're trying to make sure that what we do will solve and make a better place on that area.
Yeah, no, I definitely agree with you. Costa Rica relies so heavily upon ecotourism, but what complicates that is when there's such a huge influx of people and vehicles into these protected habitats. You guys have to toe a really fine line between, you know, supporting the economy, but also protecting what gives you guys all the tourism. And yeah, no, the fact that 500 people participated was definitely impressive to me. So yeah, good. Just want to say again, thank you to Barclay.
Last one. Yeah. I know everyone's tired. Un momento. I'll do it myself. I'm going to try not to take up too much time because I'm guessing a lot of people are over it, so.
No, take your time. Woo.
Thank you. Also, my mom and my sister are watching, so hi Mom, and happy birthday to my sister. Happy birthday. So, hi everyone, my name is Delina, and for my internship, I worked with La Tolichera, and they are a organization here in Monteverde, and they work to create a circular economy in Monteverde and reduce some of the climate causes that have been happening. So, table of contents. So this is what we're going to be going over about us. What is La Tolichera, for those of you that don't know, about the process, how does La Tolichera function, the goals and strategies of La Tolichera, the bigger picture, how to save the world with one gene at a time, or not, your purpose, how you can make a difference, and then the end, so that everybody can get their coffee. So about us, what is La Tolichera?
So I always like to start all of my presentations with a little quote to just give homage to a person that's speaking up about the issue and talking about the overall message that we'll be discussing today. Valuing the things that we own is the climate solution. And this doesn't just relate to our clothes, it relates to our world, it relates to our water, our friends, our family. Sustainability means valuing the things that are valuable, so that they're valuable to everyone, all the time, everywhere. So about the purpose, La Tilichera was created as an initiative in the 2010s with the purpose of solving several issues in the Monteverde region, the greater Costa Rican nation, and the international sphere. So they are tackling clothing waste, creating a circular economy, securing opportunities for women, and of course, creating community. La Tilichera has been able to push forward in these initiatives and has accomplished many of its goals. So about the process, how does La Tilichera function? A sustainable model. So the economía circular, so La Tilichera first starts off with materials. Those materials are then used to either repair, reuse, or remanufacture clothing items, and then it's captured and also to capture value in all states of material decomposition. So the circle, the actual circle part of the aspect. So first, La Tilichera starts off with an assessment, valoración. Materials are assessed to determine if they are plantino or platos. And plantino or platos are the branches of categorization for La Tilichera, as opposed to money and monetary values that you might see in thrift stores or other clothing stores. In La Tilichera, it's based on the amount that you give is the amount that you get, and that's sustainable. And also puntas, which is the point systems. Points are used to let members know what they can get as an equivalent, and what is used to sustain that is repurposing of other items that individuals can buy separate from La Tilichera, such as if anyone's ever seen the denim tote bags. They have some out front in the reception area in Monteverde, at the Monteverde Institute. So who supports La Tilichera? There are a lot of individuals that go into the support of La Tilichera. So one of them is El Banco de Costa Rica. The Costa Rican bank provides La Tilichera with the space that they use to manufacture and barter their items. The facility comes with proper plumbing and Wi-Fi, and of course the facility that the individuals there use to conduct their business. So escuelas, a private school issues scholarships to children whose parents work at La Tilichera, and this just incentivizes others to go ahead and do what's best for their kids and what's overall really great for their community. Organizations, local organizations, and institutes like CASEM and Monteverde spread awareness and collaborate. La Tilichera has done a collaboration with CASEM, and they also, with the help of the local organizations, they're able to establish themselves better and also apply for grants and push for more donations. And of course, clients, customers, and also the amazing women and individuals that work at La Tilichera. One of them is here. Hi! Hi! Thank you so much for all of your work, and also the individuals that contribute towards trading and producing this circular economy. So if you've ever been to La Tilichera, thank you so much, and to all the people that work there, thank you so much. All right, so the goals and strategies of La Tilichera, how can La Tilichera can apply to the world? So the goal of La Tilichera, as I said, in the international sphere is to eliminate, and what exactly are we eliminating? What we are eliminating is one of the newfound problems of the world in general, which is fast fashion. Fast fashion companies came into relevance in the past few decades as a response to people wanting items that were from runways. So fast fashion companies came in to give people the opportunity to have affordable clothing items that were from runways, which is why you have brands like H&M and Zara and Shein and all of these others, other fast fashion brands. But what we start to see emerge with fast fashion is another new concept called microtrends. So if you think back to the 50s, the 60s, the 70s, you're typically going to see that people have their a typical sense of style. So now what you'll see is something known as microtrends, which is a culmination of all of the trends or designs that people like to mimic all in one. What that does for the environment is there's just a mass overconsumption of clothing, and there's more poorly made clothes because more people want to look a certain way or dress a certain way. And of course, clothing is amazing. I love clothes, but what that comes at the cost of is that there is constant production of clothing that are poor, and they end up in landfills, which I will discuss further. And like I said, again, fast fashion produces poor quality clothes, and it also comes at the expense of poorly treated workers, and again, children. Children are some of the biggest hit targets by these fast fashion companies. A lot of forced labor, a lot of child labor, and it's never okay. And like I said again, mass pollution, because a lot of these poorly, cheaply made clothes end up in landfills. And what that also does is, because of the manufacturing process, it also means that individuals who are unfortunately the scapegoats of this scenario, they have to suffer water contamination. Meaning that not only are they the individuals that have to suffer from mass pollution and are the closest to that types of pollution, they also don't have access to clean drinking water. So just a little fun fact, well, not fun, but just to let everyone here know, it takes an average of 1,800 gallons of water to make one pair of jeans throughout the entire manufacturing process. And after that process is committed and you get the jeans rips, you don't like the jeans, they don't fit, you throw them away, and that becomes even more waste at the expense of the individuals who already have to deal with the water contamination for your one pair of jeans. So what is the strategy towards this mass consumption, towards the fast fashion, towards the micro trends? It's La Tilichera. So the strength of La Tilichera is, well, at least La Tilichera in the international sphere, is it can save a lot of non-renewable resources, and that's water. A few decades ago, water used to be a resource that we thought was for the life of the planet, but we are quickly realizing that the planet might not live for long. But there's a lot that we can do to save it, and literally just repurposing the items that you have to make it sustainable is part of that process. So restores equity and equality to the global south. And this is a really, really, really important part of the conversation that is not being had, and that is the global south is taking the hit for the global north. And what that means is the individuals in the US, the UK, France, Canada, they're able to buy the Sephora and the H&M and the Zara and all of these different fast fashion companies. But what that means is the labor cost for individuals in the global south is so astronomically low to the point where some of these individuals are not even getting paid. And that is a big contender of fast fashion companies. They want you to believe that there is just this imaginary machine that's manufacturing all of your clothes. Please know that everything that you touch, everything that you wear is made by an individual human being and a person, and that person's life is quality. That person deserves to have a good life. That person deserves to have great things. And they live in the global south, and as a result of that, fast fashion companies are using it to harm them. So also, La Tilichera encourages people to have their own sense of style. When you are repurposing your own clothes, you are giving it value, and value is, like I said previously, is so important to creating a sustainable earth. Also, it promotes value, again, creativity, community, and skill. You get to have something that belongs to you, and you get to have something that is yours. Some of the weaknesses, it could require international or multinational policy, public policy, especially with what's currently happening in the global south with a lot of workers in fast fashion companies working for upwards of 10 hours without breaks. And of course, again, children. It could require corporate ownership. But at some point, at all points during our talks in climate change, we should all be discussing what ownership at every level needs to be and what those actions need, where those actions and those words need to come from. And that comes from corporations and governments. It requires people to devote time to repurposing their own clothes. I went through the process and it took me less than an hour. Granted, there were people that did other parts of it, but it was a really great process, and now I have something that I can give back to another person, or I can wear for myself. So the bigger picture, how to save the world with one pair of jeans at a time, or not. So what happens to textile waste? This is data produced by the Pew Research Center. So 62.5% of textile waste is sent to landfills, and they just pile up. As I'll show you a graphic in a second. Exported overseas, which essentially means that it's being repurposed, but you can never really 100% know. 14.5% of it is supposedly recycled. But as we've talked with about climate change and climate action, we see that recycled items aren't necessarily cause for good. Sometimes recycled items can take just as much time and energy from the earth as actually manufacturing it, and 18.7% of it is incinerated, which is essentially it's burned, which is also not great for the environment at all. So your purpose, this is just a little meme to wake everyone up. So climate is slowly changing, is changing slowly, we have enough time. Scientists are sort of telling us climate is faster and stronger than ever, and sort of saying the future is now, we have to take action now, we have to take accountability on all levels now. So the human cost to corporate gains. So it's been reported that 60% of children in Bangladesh are part of the manufacturing process for fast fashion companies. 85% of the individuals that are not children in Bangladesh, this is just specifically from Bangladesh, from a data that I got also from the Pew Research Center, are women, and then out of those individuals, depending on the company itself, people earn $1 US penny a day to $3 a day working for these fast fashion companies. Even adjusted to the currency of Bangladesh, it is still not enough, it is still not sustainable, and it is still not right, and it will never be right. And this is part of what I worked with at La Tilichera. So I first started off by picking this design, and then I started doing the patchwork to create these pair of shorts. And just by looking at the shorts, you're probably just thinking, oh, they're just shorts. But with these shorts, I was able to save, with the help of Paula and some other workers at La Tilichera, I was able to save a pair of jeans, and I was able to repurpose all of these great resources that we should always be repurposing and putting to good use. And yeah, so tomorrow we are hosting a workshop at La Tilichera to show people how to actually go about repairing their own clothes. Unfortunately, we can't fit that in right here, right now. So if you could, please join us tomorrow from 3 to 6 p.m. at La Tilichera. That is the address. And we are essentially learning the environmental impacts of clothing waste and discovering the solution, being a part of the change that we actually want to see. If you have a pair of clothing that you don't like or don't want to use, think about repurposing it into a bag that you might want to use or a pillowcase or a stuffed animal. We want to create a world where we are all being a part of the solution for greater change. And this is the same flyer, just in Spanish. If anyone needs to read that. We're good? Okay. And now the closing. I know everyone's like, this worker, like, they're done, they're over it. So luckily, we're at the end. So this is just La Tilichera's Instagram. If you'd like to stay updated, you can go ahead and scan the QR code, and you can just go ahead and follow them, and they post updates. And it's a great way to stay involved in your community. We'll come back to that at the end. And thank you so much for listening to me. It's the end. Everyone gets to have coffee now. So thank you so much. And any questions? Questions? Oh, what kind?
What do you recommend for people in places that where, for example, La Tilichera doesn't exist, or additionally, like people that don't have sewing machines and stuff?
Well, for individuals that don't have a La Tilichera, I would say that's a part of the great change, is that you don't necessarily need a La Tilichera. It would be nice to have it. But if you go into your closet and you're like, I have this thing that I want to throw away. Instead of throwing it away, what could I do with this thing to make it last a little longer? Because at one point I bought it and I did like it. Or maybe your mom bought it. But either way, try to repurpose it. Because
So like, what are some things that
if you have a pair of jeans that you don't like, turn it into a bag. That's what I got for you. And also, La Tilichera isn't special in the means that it can't be reapplied in other areas or other climates. It can, and that's something that we should be looking forward to, is to how do we take resources within our community that are not monetary and turn them into things that people want that have value. So you see this with the Bank de Costa Rica, the Costa Rican Bank, and you see this with the school as well. Women give up their time to work at La Tilichera in exchange for their children being able to go to school. And that is a great model. You could do this in, and I wouldn't say anywhere, but you can do this in a lot of places. I can think of like my own home. Maybe not, I live in New York. But you could do this in a lot of places, and the main goal is to repurpose items.
I was just going to add some ideas to that. Thank you. Awesome subject, awesome presentation. There are definitely platforms online. I don't know if recycle is still a thing. It was when I lived in the States. And there are other ways, like on Craigslist and things, where you can do swaps. And there's also a model, I think it's called the really free market, or truly free market, where sometimes it's like a market that's set up, but there's no money exchange. And so maybe somebody goes and is cutting hair, or someone else is, I don't know, helping you file your taxes or something. And so it isn't something that requires some of the physical infrastructure and some of the things that are definitely a challenge and kind of more permanent. And then also, with clothing specifically, just have a clothing swap. I used to participate in this more with friends when I lived in San Jose, and it was super fun. I'd like make dinner or pizza or something, and everybody agreed if you don't want to make it, you use
another really big goal of fast fashion currently is to sort of dismantle community, and that's the disconnect between the global north and the global south. Because people in the global north can't visually see what's going on in the global south, they can't see the children working, they can't see the water pollution, there is a huge disconnect. And especially there's a lack of empathy in the way that we have discussions about what's going on to women and children in the global south. So again, fast fashion companies aim to create that disconnect, but by repairing your own clothes, you create community. By repairing your own clothes and reusing them, you have create swaps. And another great resource that I like to use is Goodwill if you're in the US, and also Depop if you like constructed clothes, customized clothes. Depop is a great resource. But that's it. Any other questions? No? Okay. Thank you.
Thank you, everyone, and thank you for your patience and time. Really great set of presentations. I don't have any of the words to say more than thanks to the whole group. Thank you for all your effort and time in this presentation. Let's go ahead.